Well, yeah, thanks everyone for joining us today for this webinar. This one's going to be a little bit different from our typical webinars. Often we're showing features in JMP, how to do analyses in JMP, how to do things in JMP. This one is about looking outward. How it is that we can connect JMP to other software, to other systems, to take what we do in JMP and extend it. And so I even took the title a little more broadly on my slide right here, JMP Integration and Extensibility. And JMP's really great for this. Since version 9, actually, we've been adding more and more ways to take what you do in JMP and connect it out into the world. And what I'm going to tell you about today are sort of several camps or classes of ways that JMP can integrate and extend what you're doing. And so with that, let me just go through an overview here of these methods of integration. Now, there's one I'm not really going to mention. It's integrating from inside other programs. For instance, the Excel integration. If you have Excel on your computer and you're on the Windows side, you may know there's an Excel add-in. I don't really talk about this one too much because I'm of the mind that once you have JMP, you should really be doing everything in JMP. JMP is a valuable tool, even as just spreadsheet software. So I don't talk about that one too much. The rest I am going to mention today, and I'm going to go through a bit. And the first section is connecting to data sources. So ways that JMP can connect out and pull your data in. And there's three that I'll just mention and talk about briefly. The JMP Query Builder for SAS. So if your data lives in a SAS database, using JMP, you can actually connect to that SAS database and pull the data down directly. And using the Query Builder is a wonderful way of doing this because it simplifies all the writing of SQL for you. And in fact, if your data lives in a standard ODBC compliant database, there's a JMP Query Builder just for SQL. And there's also a JMP Query Builder for local tables. And this is a version of SQLite. So this actually invokes this in the background, and you can actually use SQL to do joins on tables locally. And so we'll talk about some of those rather briefly. That's probably the simplest way that JMP can connect to other software, just by bringing your data in. The next is how you can recruit for processing or analysis other software. And of course, since JMP is made by SAS, JMP does a great job connecting to SAS on a server, or even something called SAS on demand, which I'll be showing you today. So this means you can actually run from inside of JMP an analysis that recruits SAS and all the processing that SAS can do in a cloud or a server environment. Now you can also, since JMP 9, run an analysis in R. So from inside of JMP, using some of the JSL or the JMP scripting environment language, you can actually recruit R as a processor. And so that means if there's some package on CRAN that does a particular analysis that you don't find in JMP, you can, from inside of JMP, call on R to use data you have in JMP to do that analysis and then bring back the results. And so I'll show you some examples of that. And then certainly I'll provide you with some example code. One nice thing about using JSL, once you've done a few of these, it's really easy to adapt. And finally, running analyses in Matlab. So much like how running an analysis in R works, you can also, if you have Matlab installed, recruit Matlab as a processor. So those of you who use Matlab know it has some great functionality for signal processing, for lots of different things. And from inside of JMP, just like you can with R, you can call Matlab to do some kind of function and then return the results. Now finally, this is a new type of extensibility that I want to talk about, and that's exporting your JMP models or procedures to other languages. So for a long time, JMP's been able to generate SAS procs, and I'll show you where in JMP you can do that. So if you're fitting a linear model and you want to generate the equivalent SAS procedure, JMP can actually write that code for you. That's one of the ways you can actually run an analysis in SAS, letting JMP write the SAS code and then giving that code over to SAS to run. But recently, we've also extended the ability of JMP to create score code. And so this is true or useful when you need to invoke a production environment for coding or scoring your observations. So for instance, you can do this with SAS on the server, but often you might find this with Python or C or JavaScript if you're using a local client side. So what this means is once you fit some models in JMP and come up with a candidate model that you want to deploy, you can take the way the model is actually scoring the data, the actual numerics of it, encode that into a different language, such as Python, and then put that into a web server. So new data coming out doesn't have to hit JMP to be scored. Instead, it can be scored by the server itself. So we're going to talk about all these in turn. And so I'm actually going to just move my PowerPoint aside here. And let's start with actually working with data sources. So the jump query builder for SAS, for SQL, or for local tables. And to do this, I want to first introduce you to where the jump connectivity for SAS lives. And I'm using jump on the Mac. You probably know that there is no version of SAS Stat for the Mac. And so I'll be using jump that lives on a server somewhere. And the way I set this up is under my file menu. You may have noticed if you use jump, there's a SAS submenu. And under the SAS submenu, there's the option for us to establish a server connection to a SAS server. Now, if you do have SAS running on a local environment or a network environment somewhere that your computer can access, you can actually just specify the machine and the port, connect directly to it. I'm using something called SAS On Demand for academics. So if you are an academic, you can sign up for a SAS On Demand account. There is a limit to how much data you can process, so I think you can use at most 5 gigabytes of RAM at any one time. But it actually is pretty generous and pretty fast. And so I'll point to a URL for you at the end to look how to do that. Now, setting up your SAS server connection, it seems like there's lots of options here. I'm not going to go through them with you now, but I want to point you to a place where you can get step-by-step instructions for how to set this up, because I think you may want to after you see the things we can do. And the place to go is Jump's learning library, so jump.com/learn. And there's a subsection here called Using SAS from Jump. Just a note about the learning library, if you haven't ever seen it before, this is a great place to go whenever you're trying to pick up quickly some new procedure. And so these are all ordered by types of sort of analysis class. So if you're doing time series or correlation regression, go to any of these subsections and you'll find guides and videos. Let's go to the Using SAS from Jump section, since that's what we're doing right now. So this will load up, and you'll see what we have for each of the different topics are one-page guides. And so, for instance, connecting to SAS On Demand for academics, if I click this one-page guide, it'll come up here with the URL for how to sign up for SAS On Demand, how to get the correct files for SAS to allow you to connect to it, and instructions on how to actually establish your connection. And so if you want to try this all on your own, certainly visit that learning library. Again, the URL, just jump.com/learn. All right, so since I already have my SAS connection set up, I don't actually have to do anything else. I'm already connected to SAS On Demand. And so let's start with how I might pull data from SAS if it's living in a SAS database. And again, using that SAS submenu, you'll notice there are two different options that relate to pulling in data. So browsing data and the SAS query builder. Both of these allow me to connect to the data that lives in SAS, but I'm going to use the SAS query builder even if I'm not generating a query, even if I just want to pull down a single table. And the reason I like it is that when I pull up the query builder, let's connect to my SAS app, I actually have the option of viewing table snapshots, seeing what columns are in the table. It gives me a nice way to browse the data source. So if you're not familiar with databases, we have schemas and tables. Schemas are sets of tables, and tables live within schemas. I'm going to scroll down. There's a SAS help schema here. So all the files that are referenced within the SAS help. And maybe I want to pull down one I've seen before called shoes. And so I'll find it on the left-hand side. We'll see what columns are available. I can look at a table snapshot even. And what this will do is, in a little jump window inside of the query builder, show me what data exists here. So for the 395 rows and 7 columns. If I wanted to build a query, I could place secondary tables in addition to this, but let's just pull down one table. I'll put shoes as my primary table. It'll add it in here. I can import now, or just so you see what it looks like, I'll build a query, even though I only have one table, because maybe I only want to bring in the first 4 columns. I'll select those first 4. Maybe those are the only ones that are valuable to me. You'll notice Jump can even show me a preview and the SQL code that would be necessary for this. But I'm just going to run the query. We'll play around with queries with multiple tables in just a second. What's happening right now is Jump is calling SAS on the server, that SAS connection, and it's actually going to pull down the data into my Jump data table. And there it is, the 395 rows with the 4 columns that I actually asked for. Jump has some great connectivity features here if the database were to change. So if I knew that for whatever reason they added more shoes, I can update directly from the database by clicking this little play button. These are Jump scripts. They're stored in the data table in the top left. Actually, if I right-click one and go to Edit, you'll see this reveals the Jump scripting language that's necessary to perform this query. So this is JSL, Jump's own language. And this is run whenever you click that play button in the data table. So you'll see actually on the tables we have today, there's going to be a lot of saved scripts. And this is a great way to keep your work for later. So that's one example of pulling down data. That's using the SAS query builder. I mentioned that there's also a jump query builder for databases in general. And so under the databases submenu, you'll also find a query builder. Now on my Mac side, I don't actually have a database connection set up. I only have the SAS connection. But if you did have an ODBC connection set up for a database, the query builder will look just like it did using SAS. And finally, I mentioned that there was the SQLite instantiation. That's actually a jump tables query builder. And we have a webinar coming up actually next week on Halloween. And if you want to learn a lot about Jump Query Builder, you can attend that webinar. But I just want to give you a hint of what it looks like. Under the tables menu, there's the Jump Query Builder option. And what this is a version of Query Builder. Notice it looks very similar, but it applies to local tables. And you'll see I have a number of available tables here. Let me show you those tables. I have a hypothetical situation here where I have a table of just states. I have a table of the state names plus IQ and region, state names plus population, state names plus household income, state names plus a bunch of other variables. Notice I have a lot of these tables, and notice something in common. They all have state names, right? That's going to be a key to linking the rows between the different tables. And so in the parlance of a database, we have local keys here within each table. And so the jump is going to be able to know where the rows go in each table, even if they weren't in the same order. And so the way this works, let's just keep the tables on the right-hand side. Jump's already picked the first open table as my primary table. I can select the rest of them, excluding states. I don't need it twice. I'll put it as the secondary table. Notice that when I click on each of these, Jump has found the joining operation. State matches state in each of the tables. And this little icon here is showing me the type of join. So in database parlance, this is a left join. So any states that occur in the original table will be what will be in the final table. And data in columns not found in the original table will be joined onto that original primary table. So when I build a query, like I did before, I can decide what columns I want to include. I'll just click Add All. Why not? I can define filters. So maybe I want to drag region and say I want to select a particular region to draw observations from. Maybe I even want to tell Jump to prompt me to pick a region when I run this query. And so that's an option under the red triangle here. And so I can have Jump say, hey, pick a region as soon as I run this query. Notice there's SQL that goes along with this. Jump will write this interactively. And so it'll actually update if I were to change anything in the filtering. But for now, let me just click Run Query. Notice Jump will prompt me to pick the regions. I'll just grab all of them, hit OK, and Jump has now joined the tables. So adding the columns from all the different tables to the correct rows. So query building is a great way to combine observations from different sources, and just one of the ways that you can integrate Jump with other database locations. So tables that aren't local, but tables that live on databases. Okay, so let me close all these tables. So let's move on to, beyond pulling data in, other ways you can integrate Jump. And so I mentioned that a big class of integration is the idea of recruiting for processing and analysis from other software. So being able to recruit the processing power of SAS, recruiting the processing power of R, or the processing power of Matlab. And to start, let's stick with SAS since we've been looking at some SAS integration already. And I'm going to bring up a data set, one of our favorites, big class. And I'm going to show you two things that I mentioned. So we're going to recruit the power of SAS to do an analysis, and we're also going to use Jump to generate a SAS procedure. That is, I'm going to pretend that I don't know how to code in SAS, which isn't a total lie, and I'm going to let Jump actually help me write the code to perform, I'm going to do maybe a multiple regression in this case. And to do the multiple regression in Jump, we would go to Analyze, Fit Model. And Fit Model, if you haven't used it before, allows us to define model effects, and we pick some Y response. So let's imagine that I'm predicting the weight of these individuals, and I'm going to do it on the basis of a few of my variables. I want to use height, for instance. I want to use sex. And maybe I also want to define the interaction. I'll pick height in the model effects section, sex in the columns list, and use this cross button. That'll define the cross product there. And so if I were to click Run, and I'll actually keep the dialog box open here and click Run. If I were to click Run, I'll get the output in Jump. This is the Jump analysis output. And in fact, I want to keep this open because we're going to compare this to what we get after we run the analysis using SAS. I'm just going to minimize a couple of these sections so we have a smaller window to work with. All right, so there is our jump output. Now, to recruit SAS as a processor, we have to have two things. First, we have to have established our SAS connection, which we already have because we were browsing data. Next, we have to have some SAS code to give SAS to run. And that SAS code is going to have to provide the data that is actually being analyzed. Obviously, the data live here locally on my computer, so we're going to have to pass that along too. So if you know a bit of SAS, we're going to have a data step and we're going to have a proc. It's going to be proc GLM if we're using a general linear model. In JMP, the top left section of this fit model has a red triangle. And remember, if you haven't used JMP before, you wouldn't know this, but red triangles are little menus that always let you do more things. So click every red triangle as you're learning JMP. But the red triangle at the top left of any window typically has operations that apply to the whole output or to the full dialog. So when I click that red triangle at the top left, notice there's an option to create a SAS job and to submit to SAS. So submitting to SAS will invisibly create the code and throw the analysis over to SAS. But let's actually create the SAS job so we can see what code is generated and what is being sent to SAS. So I'll click on Create a SAS job, and you'll notice the first thing we see is this data step. So the data here is being read in and passed along to SAS. These are actually the data necessary to run this analysis. Notice that we're not sending additional data that isn't necessary. We're not sending the names and we're not sending the ages. We're simply sending the columns that are necessary for this particular analysis. If I scroll down, you'll see we have our procedure statement, our proc GLM. That's referencing the data we just pulled in, and even including the alpha value that's used for the proc GLM. Our model is defined as weight is equal to height, sex, and the interaction, and we're defining sex as categorical here. And then the procedure is run. So for me to run this script, I'll go to the File menu, go to SAS, and I'll submit this to SAS. You can also do on the Mac Shift-Command-R. It'll be Shift-Control-R on the PC. When I submit to SAS, this is actually now connecting out to that SAS server, and you'll see what we are returning back is the GLM procedure. We have some additional data, number of observations read in. We have our model effects, sums of squares. Just to confirm for ourselves, let's see how these things match up. If I look under the, let's say, the F tests for the different sources, scroll across here. So if I compare to what JMP has done, let me grab my effect test section for my F tests. We have 37.28. Here's our 37.28, 0.89, 0.94. That's different. And 1.05, and so 1.053. Now notice that we have type 1 and type 3 sums of squares. So if we want all analyses to match up, in JMP there are ways to get additional estimates. So we can actually get the sequential test. That would be the type 1 sums of squares if we want a different sums of squares. So what SAS will return by default obviously will be different than JMP's defaults. Not always, but sometimes we get different analysis results by default. But click the red triangles in JMP, and you could always request more output. So the SAS connection then allows us for really any model we like that we can fit within fit model to send the analysis over to SAS and have SAS do the computational heavy lifting for us. Now the results come back as that SAS output. One nice thing, of course, about doing the analyses in JMP is that you get interactive output that's built to work within the software. But there are times, especially when you have very large data sets or you're running very complicated models, for instance, very large mixed models, and you happen to have a SAS server running on a very quick machine, it turns out to be a lot faster to submit your analysis and having your SAS server actually do the analysis for you. Now, fit model is just one place in JMP that you're able to do this kind of analysis and send it over to SAS. And so fit model is a great place because you can fit many different types of models within fit model. But let me show you one other, and that's actually doing it as a time series. And to do a time series, I'm not going to use big class. That's not a great data set for this. So I'm going to go to sample data. I'm going to go to open the sample data directory because I know I want to pull up in a specific data set. I'm going to pull open the Raleigh temperatures. And so if I can find Raleigh temps. Oh, of course, it's under the time series. subsection here, and Raleigh temps. So these are temperatures for Raleigh, North Carolina, in particular years across different months. And so good data for running a time series model. And so in JMP, let's start by opening the time series platform. So specialized modeling, I'm going to go to time series. We have to define one thing for this model. So the actual time series, the data are already ordered. So we can just pick temperature and put that as our Y. If we'd like to define an X or a time ID, we can, but we don't actually have to do that here. We can just leave it blank. So our basic time series output is given here with basic diagnostics and our time series plot. Under the red triangle again, we can fit different models. So notice ARIMA here is one type of model I can fit. So I'm going to fit an ARIMA, and I'm just going to do this naively, just pick some parameters here, just because what I want to show you is a place in JMP where we can also request the analysis to be done in SAS. Now, this is not a particularly good model. Our predictions go pretty wildly poor after 130, but I want to draw your attention to the red triangle next to our model. And that red triangle also has the option of creating a SAS job and submitting this to SAS. And so again, I'll create a SAS job so we can see what's necessary. JMP is reading in the temperatures, and our actual model that's being sent to SAS, or the procedure, is proc ARIMA. So it's going through and using the same terms that I had specified. Not very good terms to specify, but using them nonetheless. So let's submit this to SAS just to see again for ourselves. I'll do submit to SAS, or I could have done Shift Command R. This is again pulling the connection to SAS. The first thing you see is actually my GLM. That's an output window that's still open there. And so if I scroll down, I can see my ARIMA procedure. And so it's giving me the lag plot, just like I saw in JMP, autocorrelation, and additional output. So again, not often necessary if we're running these on small data sets, and JMP could be just fine for that. But if we had billions of observations or very complicated models, knowing that you can throw these to SAS is actually a great way to handle very complicated analyses. It also means if you're sharing your results or your models with others, you can generate this and simply share with them what you were running in JMP, but in a language that they may understand. And so a nice way to make sure your colleagues know what you're doing. And so two places in JMP that are very useful. Fit model is probably the most common way people are generating those types of code, simply because fit model is so flexible in what it can fit. So for instance, if I were fitting something categorical with some continuous predictors, JMP knows this is a nominal logistic, and if I were to create the SAS job, JMP's going to know what to use, the proc logistic. And so JMP is very smart about how it writes these codes. If I were to specify something as a random effect, let's say, so if I have height as my outcome instead, sex, and maybe I had multiple observations for all the different students here, if I had marked that as random, so JMP knows that now students are random and we have multiple observations within students, JMP's going to know that this is now a mixed model. And so JMP's very smart about how it's going to create these codes. And if you know specific customizations to the SAS code you wish to make, like you wanted your degrees of freedom not being Kenward Rogers adjusted, but using Satterthwaite or some other specification, you can make those changes and actually run your code directly from JMP. So a lot of flexibility there. All right, so that is integration from the SAS side. And so we looked at running analyses in SAS. We also looked at generating the SAS procedures from inside of JMP. And so what I want to move to now is something that's come about since JMP 9, which is integration with other analytics software. So specifically R and Matlab. And I'm going to focus on R, but I want you to note that everything I'm going to show is equivalently done if we were running Matlab procedures. And the reason I'm going to use R is because it's great, it's free, and any of you out there can get it. Matlab, of course, is specific commercial software that you may need a license for. And so to talk about R, let me first draw your attention to a place in JMP where you can get a lot of scripting help. Because what we're going to have to do to make this connection to R is use some JMP JSL, the JMP scripting language. And a great place when you're starting out is under the help menu and using the scripting index. So we're going to use this a lot today. Now, if you've really never seen any JMP scripting, I hope you know that under the help menu and under books, there's actually a whole scripting guide. So this is a PDF that's included, written by our wonderful documentation team that actually takes you through a lot of the basics of scripting. If you look at the page count, maybe you get the impression it's more than just the basics, 730 pages. And so a lot of content in here, but of course we want this to be sufficiently documented. And so a lot of the guide here is really useful if you're trying to find specific sort of documentation on a topic. I wouldn't suggest you read this cover to cover as a way to learn how to script. But it is great that it's all built in. And the scripting index is a wonderful way to find the particular thing you're looking for. Now, if you are interested after you see this, or you already have been interested in scripting, I would make one recommendation as something that you could read cover to cover, which is the JSL Companion. And this is Applications of the Jump Scripting Language. And there's actually a new version of this book coming out in probably about 6 months, let's say. But the JSL Companion is a wonderful, wonderful book that takes you through really case studies of coming up with applications using JSL. And so a lot of the things that you'll learn about in this book will be useful when you're connecting to other software. Because what we're going to end up doing is building a little interface in Jump that allows us to connect to other software like R or like Matlab to recruit the analysis and then bring back the result. So this is a great book as a starting point if that's something you want to do more of. All right, so the reason I brought up the scripting index is I want to draw your attention on the left. I've selected the subset of features called functions. So functions in Jump. And you'll notice that there's one for Matlab, one for R, and one for SAS. I mean, there's certainly ones for others as well. But those are the ones that I want to draw your attention to. And specifically, if I click between R and Matlab, you'll notice if you focus on the items here, that there's actually the same functions for both R and Matlab. There's functions that allow you to control, to connect, to execute, to get graphics, to initialize, and we're going to step through a lot of these. But these are functions that essentially form the connection to R from inside of Jump. And there's a few of these that are of a special importance, ones that are going to allow you to do most of the things that you'll do within Jump to connect to R. Now, the first is initializing an R connection. And R init is what does this. So actually, I'm just going to right click in this little window. I'll click Run. And what this does is initializes this TK proxy. It's a proxy server that runs between Jump and R. And so that's the version of it. It's now running. And that means I can actually submit code using R submit to R. And so if I were to run this code, R submit, this is actually just generating a random normal. Let me actually just run this here. I'll right click and run this part of the script. So this is generating in R, this random normal. It did it with a function, and it actually also said do a plot, make a histogram, and color the plots and color the points that are greater than 1.669 on either tail. And what you saw pop up, this is actually not a Jump window, this is a Quartz window. This is running from R, and I actually have my R console here sitting over in the other screen. But what this is doing is actually running in R. Let me make it a little bigger here so it can actually fit again. The analysis, and R is producing that graph. So let me run it again, and you'll see what happens sort of in the background is it's generating the code and then now producing the output. So even though I'm in Jump to run this submission or to come up with the code, R does the heavy lifting here. R is doing the work and shooting back the result. And so that's what R submit does. So once a connection is initialized, you can now throw an R code, and that's what this all is in the quotes, over to R, have something happen, and then if something happens automatically in R, it'll pop up. Or, and this is what you'll have to do a lot of times, is you'll actually have to get something back from R. So if something happened in R, perhaps maybe it produced an analysis result, perhaps it calculated a p-value, you want to pull back from R that thing that was created, number, a string, a matrix, a data frame, whatever it is, you can pull it back from R and use it as a variable in Jump. And so those specific functions are the ones we'll often be using. There are some others. Specifically, you can tell R to do something, control R from inside of Jump. You can pull back the graphics that was last written in Jump. So the one that popped up before, we can tell Jump to grab it as a Jump object. And then you could do other things like sending a file to R, which you often do when you have data in Jump, and some other features here. And then finally, once you're done with the R connection, you just terminate it. And so I'll run this right now. And what that does is shuts down the R connection. And so it's no longer connected to Jump and not willing to accept commands. So those are the basic building blocks of building an R connection. And so what I want to do for you now is take you through a few scripts, one that's actually in your sample data and one that I wrote, just so you can see an example of how you might weave together these different features or these different functions to make a usable application that does something you actually want it to do. And so let's keep our scripting window. I'm just going to move it to another screen, but I'll still have it around. And what I want to pull open is a sample script. And you may not know this, but under the sample data library, so under your help menu, there's actually a whole sample scripts directory. And so these are scripts that have been written and included with your version of JMP. Lots of cool things here. So demonstrating bootstraps. We have scripts that demonstrate concepts. There's interactive demos that are great for teaching. Huge amount of great stuff in here. But for our purposes here, I want to open this first one, the JMP to R Bootstrap. And I'll click Choose. And what this is an included script. And I should have mentioned, we're looking at this in a script window in JMP. Yours may look slightly different because I've just turned on line numbers, and that's an important thing to do. If you end up coding a lot, having line numbers is a really useful thing. To modify any of the settings in JMP, go to your preferences. On the Mac, it's under the JMP menu. On the PC, it's under File. And I actually just turned on under my script editor a couple things, specifically code folding and showing the line numbers. Very, very useful things to turn on. So in this script, what this is going to do when it runs, and I'll actually just run it first, then let's step through how it's written. What it's going to do is bring up this select columns. It's generated me some random normal data just as a way to give us a data set to work with. And the whole purpose of this JMP to R Bootstrap function is for us to take those data, I'll select them to Bootstrap, and what this will do is sample from this table repeatedly. How many times? Well, we can tell it. Let's just do it 10,000 times. It's going to take a sample 10,000 times with replacement, and it's going to calculate something every time it takes a sample. And we can select this. What bootstrap statistic do we want to compute? And so what if we calculate the mean on every single one of those 10,000 samplings with replacement? This is called a bootstrap for the mean. It's a way of finding an empirical confidence interval. That is a confidence interval that would occur if we were to continually sample from this observed data, which is a proxy for what would happen if we sampled from that population, or at least the population that realized this sample. So I'm going to click OK, and it's going to happen very quickly because R does that. When you throw an operation to it, it just starts processing. So for 10,000 samples that were made, and I actually have the 10,000 bootstrap samples here. Let me expand my window here, and you'll see there's 10,000 rows. Every one of these cells is the mean that was calculated from a sample that was drawn from this original table with 50 observations. So what we get here is the distribution of resampled or bootstrapped means. And what is calculated for us at the bottom here is the bounds of the 95% confidence interval. Where did we observe 95% of the data? Well, 95% of the data occurred between 0.4 and 0.08. And so this is a way of bootstrapping a confidence limit. And we can do this even if we don't have confidence that the data started off as normal, or with any type of data, really. Bootstrapping is a great way to form these confidence intervals. Now, you may know, if you're a JMP user, if you're in a platform like distribution or any platform really, we can actually right-click and bootstrap from inside of JMP. It's now a feature that you can do directly. But our purpose here was to demonstrate that we can get R to do that bootstrapping for us as well. And that's what this script is doing. And so the way it's going to work, and I'll keep our little scripting index to the right-hand side here, because we're going to look up a couple things as we're going through. What this script does is recruits R as a processor, and it's going to do that after it throws the data we have in JMP over the fence to R. And let's step through, and this is not a webinar on teaching scripting, but I do want to point out a few important pieces of how this script works. And then we'll move on to a script that generates not an analysis, but some graphics. And so the important point I want to show you is that we start off just generating a table of random data. If I run just this, you'll see what we get is our table of random data. And that was where we started. That's how we had data in order to send over to R in the first place. The next section here is a dialog box. And so this is a way for JMP to ask or prompt a user to do something. And that was the dialog box you saw when I ran this before. So let me actually just run all of this above. And so this is what this section here, the BD equals column dialog. This is actually a dialog box with some settings. And so that's how it's asking us what we want to compute. And it gives us the option to select a column. All right, so that part of the code doesn't have to do with R. That just has to do with giving you the function in JMP to select and to pick. And so that's something that the JSL companion will help you learn how to do really easily, building dialog boxes. Now there's a bit of this that pulls the parameters from the dialog box. That is, what does the user choose? Then there's a part of this that actually grabs as a matrix, so just as a type of object in JMP, the values from that normal table that we just randomly created. So that first table that was made in JMP, what happens is for the section I selected down here, so right here, what this says is grab this whole column of 50 values, just get it as a matrix and call it BVMat. And that's where we're going to end up throwing over the fence to JMP. Let's skip over this part for a section. I want to point you to really where the magic is about to happen. And this is where we're submitting to R. And so you see there's the R init, which remember, R initialize is just initializing the R interface for us. So we have a connection to R. R send, remember I told you R send is just a function that allows us to throw to R some object. And a matrix is an object in JMP. And so when I send this to R, R itself, so if I were actually over in R and I were to call BVMat after I send this, that's an object that R has access to. It now has that as a variable, actually as a matrix. Next, we do an R submit. And remember, R submit is throwing a function or a statement over to R to do something. And the way we're going to do this, and it's going to look a little complicated because we have to use a special function in JMP called evalinsert, which is sort of a bit of magic. What evalinsert does is it looks for a couple upward-facing carets. And whenever it sees something wrapped in upward-facing carets, it'll replace what's in there with the variable that JMP is using it. So for instance, if you scan along here, you'll see there's a point where we get to number of reps. We had some up here as well too, but let's look at n reps. N reps for JMP, this internal piece, that's actually a variable. We set n reps above here to the number of repetitions that somebody entered in. Remember, I put in 10,000. So this function right here, this line of code, pulls from that dialog box what I entered, the number I entered. And then what happens with evalinsert is when it hits this part of the code, it substitutes n reps for the number 10,000. And what that means is it goes through this R code. Everything inside of the quotes here is just plain old R code. And what it's going to do as it goes through that R code is substitute in all the selections I as a user actually made. And then when it sends it to R, R never sees quote n reps, it just sees 10,000. And so I'm able to basically substitute in any selections I make as a user into the code that I end up sending to R. And that's the magic. And so all the selections that were made above get entered in here. And then after we're done, we pull back from R the results. And so that's all the rest of this. Now the final bit, this just generates a new window with the distribution output. So we're able to take what was returned from R and actually build a little dialog for JMP. And that's how we build that output. And so when we put it all together, let me run it again. You'll see that we start with our columns list. We make a selection. We change that n rep value. I'll do 100,000 this time. It's going to be fast no matter what. I can select a different statistic. All of that gets wrapped together for R, and then we pull back the results. And so there's my histogram of results pulled back from R. And so pretty magical. So we were able to, without a huge amount of customization, obviously this is a built-in script, and if you're not familiar with JSL, it may seem a little intimidating, but I promise you it's not. And getting a little bit familiar with some of the architecture of JMP scripting means that you too can build these for almost any type of analysis that you do in R. And I'm going to show you one other that I put together, one that actually is for graphics. But before I go all the way there, I do want to point you towards a very useful utility. And I'm not going to demonstrate it here because actually our intern over the summer, Julia Gong, brilliantly put together an R to jump add-in builder, and she has a video here on how it works. And so if you just search on community.jump.com, the Jump to R add-in builder, this is something that can help you build some of those dialogues. And it's Windows only right now, but Julia said that she's going to work on a Mac version for us as well. And so hopefully I'll be able to report back next time I do this webinar that there's a Mac version. But watch this video. This is a nice way to stepstone your way to creating some of these add-ins. But I do want you to see some of the code behind them, because I think it's illuminating to see that it's not even too complicated. So just wanted to point that out. But the next script I want to show you is one that I wrote that's actually for creating certain plots in R that you can't do in Jump. And to do this, let's pull open our favorite big class again. And let me just demonstrate what this script will do. And this is available on the user community as well. And I wrote it with a lot of comments, so you should be able to adapt it and try it out yourself. But let me run the script first. And it's pulling open a lot of packages in R. And what it's going to ask us for are some columns. And I have some buttons here to create different kinds of plots. And let me show you what it creates. So let me do height, and let's do it by age. And I wrote this at a time when Jump didn't make violin plots. Jump now can do these. But if I click Make Violin Plot, this throws over to R these two columns and actually generates us violins. Violins are kind of like folded distributions. And so they're ways of seeing the data, to show the distribution of the data, but also without a lot of intensity. So it's a nice way of doing this. The overlay plot is a different type of plot that I really like. This is showing really the distributions, but layered on top of each other for the different ages. This is also something you can kind of do in Jump, but still not exactly this way. And so I wrote this because I just like these plots a lot. And I even have a way to customize. So if I click Plot Means, make an overlay plot, it'll even put the means in for each of those. So how did I accomplish this? So let me actually close. And there's, again, a lot of detail in here, but I want to show you the main pieces of this that really are where the magic happens. And so I have this folded expression here, load expressions. And this is a bunch of pieces of code that I call at different times in the script. And so this gets run first. And this basically just loads into memory a bunch of functions that I can call. And so that's the first thing that happens. Then I tell Jump to initialize the connection to R, which runs this part. So it initializes, and then it loads some libraries. So if you're a user of R, you know ggplot2, implier, and using R. And so it loads those libraries. It checks to see if there's a data table. If there is, I already have big class open. And then it draws the window. And the window is where we ask the user again for input. So generate questions and have the user select things. And so once a user makes a selection, right, I clicked Make Violin Plot that first time, it says, well, if a user presses that button, then run Make V Plot. And let's go back up. Remember, that was an expression I loaded up earlier on. Make V Plot is a function. And so if I expand this, it's literally an expression in Jump's terminology. The expression is just a way to hold a bit of code that only gets run when it gets called. And so when that button is clicked, Make V Plot gets run, I pull from the dialog box the items. That is, I actually pull from there what the user selected as the Y variable and the X variable. I specify the current data table is called DT. I assign it a label. I send to R, the data table. And then I submit using our favorite evalinsert. Remember, evalinsert is just a way of telling Jump, hey, substitute in anything you see inside the carets. And so what I do is I run simple violin, it's a function. I substitute in the Y column name right here. And I say, as a function of then the X column name, and then I define the data as DT, and I even colored it light gray. And so make vplot is a pretty simple function. In fact, if I wanted to add another function to this ggplot script, it wouldn't even be that hard. I can just take this make vplot section, and maybe I want to make something different, like a box plot, make bplot. And I actually even have a window open here. I just Googled ggplot, and there was a whole section down here. Let me scroll down where there were some pretty simple box plots. And so here's one. So ggplot, I call the data set, I call the column names, and then I call it with the genome point and genome plot. And that'll give me this box plot. And so let's try to adapt this. I'm going to grab this code and copy it. I'll come back over to jump here. So I have my new section, make bplot. Instead of calling simple violin plot with the DT, I'm actually going to select right inside. So this is right between those brackets. Let me paste in make gplot. I'll say DT is my data table. I want to call with the column names that the user or me selected. And so the way I did that before, if I look in the make vplot, and this is how you might just adapt my code, the Y is here. The way they do it is Y is the second specified. Workshop is the X. Okay, that's actually all I have to adapt. The only additional thing I need to do is make a separate button now. I need jump to have a way to ask the user if I want to make a box plot. And so let me go down to my window. I'm just going to copy the button box here, return, paste it, make bplot, make box plot. So that's 100% of the customization I need. Let's see if it works. I'm going to click run. Jump's opening up the dialog box. I now have a new section. Let's make box plots by age, and let's do it by height. And fingers crossed, there we go. So now we've made a brand new function. And if you wanted to customize with ggplot all the different ways it can be run, you can add all that code in the script, and then Jump will, every single time you click make box plot, make it just that way. And so notice that with a little bit of knowledge about how JSL is working, then you can customize really my code or anyone else's code on the community to make your own connections to R or Matlab or any other really processor that Jump is able to connect to. And I will mention Jump 14 comes out in March, and there's a very good chance Python will be the next connection too. So if you're a Python programmer, everything I just did here at R, you can also probably do with Python. So no promises there, but we're all hoping that that's the next one as well. So that's connecting to R. Now, I did mention there's one additional class of ways that we can do in extensibility with Jump, and that was this generating models and procedures to other languages. And so we've been recruiting for processing really other languages. But what if we just need to create something in Jump and then share it into another language? And to demonstrate this, I'm gonna open up something that we presented just at Jump Discovery, and I'm gonna borrow heavily against work that our host Mia had done here. And so this is a data set with data for St. Louis. And what we have are data on all the houses for sale in St. Louis. In fact, if I just pull in latitude and longitude, drop them in here, let me right click graph background map and throw on a street map service, we can see these are all the houses in St. Louis that we pulled down. We got about 4,800 of them that are currently for sale. And so we were trying to build some models, or Mia was, to predict price. And the reason why was we wanted to build a model that we can deploy, a model that we can put somewhere such that if you imagine we had real estate agents who were out in the field, that would allow them to hit our server and score a new house, something that our model had never seen. And let me give you a peek at the end product. Here it is living on AWS. This is built by one of our pretty brilliant developers, Nassif. And this is actually running live on Amazon AWS. And for instance, let's imagine that you were browsing a house here, right there in St. Louis, and you knew that it was 3 bedrooms, 2 baths. You had listed it just 19 days ago. It had a huge area, and it was built pretty recently. And if you click predict, what Jump will do, not Jump actually, what AWS is doing is coming up with a prediction. And behind the scenes, what's actually happening is all these parameters are being read into a neural network that we fit inside of Jump. And we fed the score code from that neural network to Python. And now in AWS, the scoring is happening behind the scenes via the Python code. So how the heck did we get there? Well, in Jump 13, there's something called the Formula Depot. And the Formula Depot allows you to take models you've done in Jump, and this is a Jump Pro feature, and create score code out of them. So not something everybody needs, but something that if you do need, allows you to save an incredible amount of time. So let me just run a neural network here that Mia has saved to the data set. And remember I said that in the data set, these are scripts. So this is the script for running the neural network, but inside of Jump. So this is not Python code. This is just the Jump neural network. Now, under the red triangle for each of these neural networks, and let's just pick the top one. These are different methods of fitting a neural network. I'll just show you quickly. This one is with just 3 tanh nodes, and this one's a bit more complicated, so multiple layers and different functions. Let's just pick the top one, and I'm going to go to this publish prediction formula. Publishing means taking the prediction formula, how this model makes predictions numerically, and it's going to put it into the formula depot. And so this is actually the factors, what's created, and the target. So we're predicting price. Now under the red triangle next to neural, there's a red triangle. Or sorry, next to the name of neural, there's a red triangle. And this gives us a number of options. We can take the formula here and copy it to the clipboard if we want to use it in another window. We can save it to the data set if we actually want to score data directly in this table. But remember, we're going to have to feed this up to Amazon. So we are not doing this in JMP. We need to create code that we can pass along to our data scientist, to Nassif. And so we're going to do this with Python. And if I click generate Python code, what JMP generates for us is actually in Python how to do this scoring. And so what it does is defines the types of variables we need as inputs. It actually defines the types, the class of variables they are. It defines the layer structures. These are the hidden layers, and these are the nodes. And it goes through and actually takes all the parameters from that neural network. And what this means is, and this is a whole lot of code that we would have had to do manually if we didn't have this sort of saved to Python output. What this is doing is returning at the very end, after taking all the inputs, it's just returning predicted price. So what we essentially do in passing this along to our developer, when we stick it actually in the cloud here, all we're doing is embedding within Amazon this function. And we know we can pass it these parameters, and we know once we've done that, it can pass back a predicted price. And so that sort of extra connection is what we were given with Formula Depot. Now, Python's not the only way we could have saved this out. Notice I can generate SAS code. So if you have a SAS server that's running and you want to score in real time, maybe billions and billions of new houses that are being tested, you can do this as a SAS code. There's the option of saving it out as SQL, so native language for a lot of databases. Even JavaScript. So if you actually have a client-side web page, so something where you don't want a server to have to run this, but you actually just want it running locally, maybe there's no internet connection, this is actually something you can embed as JavaScript in a web page. So it can run without any dependency on any server. So JavaScript is a really beautiful language for that. And finally, there's even C code. So this won't apply for most of you, but for anyone who does microchip development, C is really versatile and you can embed it directly on a chip. So if maybe it doesn't really apply for the housing case, but if you had chips on an assembly line that were checking for failures, and so you had a very complicated model that can look at hundreds of different sensors and detect maybe if something's about to fail, you can encode the C on an actual chip and have the chip throw a flag. And so maybe a red light or an alarm or something pops out. And so the extensibility sort of vision here is in JMP, build a model, build anything that does the prediction you need it to do, and then take that model into a different language, take it into the production or to the live environment, and then allow it to work with data that JMP has never seen. All right, so that's the Formula Depot. So just to remind you, that is actually anywhere in JMP you can save a formula. There's publish prediction formula. So in JMP Pro, you're able to do that. And you'll notice there is also the SAS data step here. I didn't show this before, but if you wanted to create a neural network and have it run in SAS, you could as well. But this prediction formula is a really powerful way of extending the power of JMP. All right, so let's just review. We looked at a number of ways that JMP integrates and extends. And again, this is a different webinar than our normal ones. You know, I'm not showing things in JMP, but this is how we can take what we do and push out, or take what we can do out there and bring it to JMP. And so we talked about connecting to data sources. We did it via SAS. We did it via SQL. We even looked at the local instance of SQLite. We talked about recruiting for processing. So we recruited SAS as a processor by using SAS on demand. And again, if you go to jmp.com/learn, you can see all the instructions on connecting to SAS. We recruited R. We looked at a couple scripts that did some basic things. And I definitely want to point you to the community, community.jmp.com. because you can download the scripts that you just saw me running as well as other people's. And so certainly try this out on your own and get that JSL companion. If you're interested in learning more about JSL, just a little bit of work can extend your functionality in JMP so much. And it takes you from being really a power user to being a JMP master, having just a little bit of JSL. And then we didn't look at it, but notice that any of the things I showed you with connecting to R exist for Matlab as well. So if you have Matlab installed, the TK proxy can connect to Matlab just like it does to JMP, or does to R, and all the kinds of ways you can connect and recruit exist as well. And then finally, we looked at kind of an exciting new way for JMP to extend itself, and that is generating the production score code. So we generated it for Python, for C, for JavaScript, for SQL, for SAS. This just allows us to take what we do in JMP, these models, and push them out into the world, push them out live. And so taking what you've done, all the work you've done to predict, and then putting it somewhere such that new data can come in, and without ever having to touch JMP again, those new data can be scored and predictions can be made. So a lot of really fun stuff that you can do, a lot of really useful things you can do, especially when your data needs aren't just fully contained in JMP. As all of you learn JMP more, there's so much you can do in JMP, but sometimes you have to look beyond the walls of JMP, and we're all really happy that we're getting these tools to do that more easily, more efficiently, and more powerfully.